Welcome. Today we're going to talk about complex numbers and performing operations with complex numbers. So go ahead and take your notes out and remember that you're able to pause the video if you're falling behind or rewind the video for errors you didn't quite get the first time through. Also remember to jot down any notes of areas that you might be struggling with so we can answer them during class. Okay, a little history of complex numbers and what they are. Long ago, mathematicians, when solving quadratic equations, realized their solutions were not always a real number. They were ending up with solutions that looked like the square root of a negative expression or a negative number. To overcome this problem, mathematicians created an expanded system of numbers using the imaginary unit I. Now, if you recall what I is, from the previous lesson, we learned that I is equal to the square root of -1, and it enabled us to simplify that to an imaginary number. So complex numbers are the expanded system of our normal number system with using the imaginary number I. So let's kind of take a look at what a complex number looks like. And again, bear with me, I'm learning to use my tablet. And I'll try to write as neat as possible. So complex numbers take the form of A plus BI, where A is a rational number, or excuse me, real number, and we call that the real number part. The BI is called the imaginary part. So a complex number has a real part and imaginary part. And notice in the form of a complex number, the real part always comes first, followed by the imaginary part. Okay, so let's look at some examples of complex numbers and what they look like. So here's an example of complex number. Complex numbers look like 3 minus 4i, or -2 plus 6i. We can even have fractions. We could say 1/2 minus 3/4 I. Now these are all examples of complex numbers. They can be positive, they can be negative, they can be fractions. They can, like I said, they can be negative. They just have to have the I part in them. Now what happens if they don't have the I part in them? Let's take a look at some of those. Now these are still complex numbers with their special one, and we're just going to label these non-examples. Why 4 is still a complex number. It's also a real number, and that's what we refer to it as. And what it's basically saying is, hey, look, my imaginary part is 0. So the numbers you've been used to using are still complex numbers, but we just refer to them as real numbers. The numbers we learned in the previous lesson, like say -3i, they are still complex numbers, except this time the a part is negative, or the real number part, excuse me, not -0. The real number part is 0. And my form is bad. That should actually be 0 minus 3i. So while we just usually say the imaginary number -3i, it still is a complex number. And this is actually called a pure imaginary number. A pure imaginary number. Okay, let's kind of move on and take a look at our lesson. All right, so today we want to perform operations on complex numbers. So if I gave you 3 plus 2i, and I wanted to add it to another complex number, -2 plus 4i, how do we do that? Well, the beautiful thing about complex numbers are they're handled just like polynomials. This is essentially adding two binomials. So if you dig back to Algebra 1 and remember polynomial operations, we're going to do the same thing. And the key step to polynomial operations, we're simply combining of like terms. So I'm going to drop my parentheses. I'm next going to group up my like terms. So with 3 and the negative 2, and let's change color for the imaginary parts, plus 2i plus 4i. And I can do that because that's the associative property of addition. Sorry, excuse me, the commutative property of addition. We moved to, that's the commutative property. Now with some simplification, I can say 3 minus 2 is 1, and plus, to the imaginary part, 2i plus 4i, 6i. So adding these two complex numbers, I came up with 1 plus 6i. What was the key step? Simply combining our like terms. Now, usually the misstep in this, or where kids usually go wrong, is simple addition and subtraction with positive and negative numbers. Okay, so be careful in your integer operations. Let's take a look at another example, similar. So let's go example, negative 2 minus 4i. This time we're going to subtract 5 plus 3i. Okay, and again, I apologize about my writing. I'm still learning to write on the tablet. So in subtracting complex numbers, it's essentially the same as binomials. The key step is to distribute through the negative. So as we subtract, we have to make sure we distribute through the negative to both terms. And in doing so, we get negative 2i, and notice I'm dropping the parentheses. A negative times a positive is a negative, so it'll be minus 5i. Let's change them to red. Oh, don't like that. Let's erase that real quick. So again, we're distributing through the negative. There we go. And the key step is everybody, if they miss this problem, forgets the second term. You need to distribute through the negative there, so that positive 3i becomes a negative 3i. And now the problem is simply like the previous example. We're going to combine like terms. So over here, we distributed through the negative. I'll abbreviate distributed. And then it's combined like terms. So as you look at these problems, don't look at them as something totally new, because if we replace the i's with x's, they look similar to the polynomials that you've done in the past. So i's, x's, think of them same even though they are different. I actually represent something like x is a variable, but the operations are handled the same. We're simply going to go combine our negative 2 with our negative 5. It gives me negative 7. And our negative 4i with our negative 3i. That gives me negative 7i. Notice the form again. The real part is in the front. The imaginary part is second. Okay, so we looked at addition and subtraction and saw they were very similar. The only difference being distributed through the negative on the subtraction. Let's take a look at multiplication. Now multiplication follows polynomials just as the other two operations did. So if I take 4 plus I times, or multiply it with negative 2 plus 3i, I'm going to multiply using the distributive property. Okay, so I'm going to take my 4, I'm going to multiply it using distributive property to everything in the following parentheses. So I'm left with 4 times negative 2 is negative 8 plus 12i. Second distributive property, I'm going to multiply the I to everything inside the parentheses. So I times negative 2 is negative 2i. And I times 3i is positive 3i squared. Okay, just in polynomials, we combined our like terms. So we have negative 8. We have two like terms here and here. 12 minus 2 is 10. So I have 10 i's in them for a middle term, plus 3i squared. Okay, this is where it changes a bit. To simplify or put it in complex number form, we can't have I squared. Now, lucky for us, we learned that I squared through a simple substitution is nothing more than or equivalent to, think the previous lesson, negative 1. So we have to convert all our I squareds to negative 1. So after substituting it in and performing a little simplification, 3 times negative 1 is simply negative 3. So we have to take care of the I squared. That was the key step. Okay, finishing the problem off, putting it in the right form, we're just simply going to combine the negative 8 and the negative 3, which is negative 11, and that goes first because it's the real number part, followed by the imaginary part of 10i. And now you have multiplied two complex numbers. Okay, that is the end of our lesson. So let's kind of recap what we did. Complex numbers have a real part and imaginary part. They can be added, subtracted, and multiplied, and these operations are essentially the same as the operations you performed with polynomial expressions. The difference being in multiplication, you have to get rid of the I squared. That was the key step, the I squared. Change it to a negative 1 and write it in the form. So go ahead and tidy up your notes, add some explanation where needed, and we will come back in class and answer any following questions and do some more practice problems on these. Okay, I hope you enjoyed the video.